The global conversation about artificial intelligence performance is heavily one-sided. Right now, capital and research focus almost exclusively on the machine. Optimization efforts center on system accuracy, safety protocols, and alignment with human intent. This approach assumes the human participant is a fixed, stable variable within the equation. It also presumes that workers will naturally adapt as AI capabilities increase exponentially. In complex operational environments, these assumptions lead to failure. Humans are neither fixed nor naturally adaptive to this level of technological change. Engineering only the machine addresses a single component of a much larger system. Optimizing one side of a two-party relationship caps the technology's true potential by ignoring the interaction itself. This wireframe illustrates the true performance ceiling of AI interaction. Software capability is only one half of the limit. Performance is defined by the dyad, the combined capacity of the human and machine working in tandem. Pairing high-capability machines with unprepared humans guarantees a degraded result. We require a formal discipline to address this, Human Readiness Architecture. This provides the framework to engineer the human side of the relationship. Enterprise ROI depends on architecting human capacity with the same rigor applied to algorithmic models. Standard AI models follow a linear logic. Better training data creates better models, producing better outputs, leading to better outcomes. But this chain breaks down in real-world applications. Human readiness bridges the gap. It dictates input quality, governing the exchange, and ultimately securing the outcome. Without this readiness, performance suffers. Poor quality prompting limits what the AI can actually produce. Cognitive and emotional noise from the operator leads to the systemic misinterpretation of AI outputs. Relational drift occurs, where the working relationship degrades through distracted or reactive engagement. Leaders often mistake these human readiness failures for AI model limitations, leaving the true performance gap invisible and unmeasured. Standard digital literacy training fails because it only addresses a fraction of this performance gap. Human Readiness Architecture uses 7 dimensions, starting with 2 foundational bedrock layers. Psychological readiness is the active awareness of one's unconscious biases. Without it, skilled humans distort AI outputs through defensive thinking. The second foundation is pattern recognition readiness. This is the cultivated capacity to identify signals, connections, and emergent meaning within complex information. Deep pattern recognition requires cross-domain experience and longitudinal observation. Technical tutorials cannot shortcut this development. Without these 2 foundational bedrock layers, technical skills remain fundamentally unstable, causing the dyad to fail under extreme operational pressure. 5 operational dimensions stack upon these foundations. Cognitive readiness enables the operator to tolerate ambiguity and hold complexity during the interaction. Relational readiness involves engaging the AI as a collaborative partner rather than a tool to be operated. Epistemic readiness allows the human to contextualize and appropriately weight AI outputs against existing knowledge frameworks. Emotional readiness requires the real-time regulation of internal states to prevent the distortion of inquiries. Finally, physiological readiness concerns the biological nervous system state at the point of interaction. Stress and fatigue impair the higher-order brain functions required for AI partnership. Every interaction involves the operator as a complete biological system. Total human systemic regulation is therefore a prerequisite for organizational performance. These dimensions of readiness directly impact systemic enterprise governance and risk. Current governance frameworks remain incomplete because they regulate machine design and data practices exclusively. Standard assessments ask if the system is ready to be deployed. They fail to ask if the humans are prepared to operate it. Shifting this focus transforms governance into a bilateral readiness mandate. In financial services, healthcare, and national security, the operator state carries legal weight equal to the AI's code. Regulatory frameworks like APRA's CPS 230 emphasize the integrity of these working relationships for operational resilience. In regulated environments, human-AI relational integrity constitutes a measurable compliance variable. Human readiness is distinct from generic change management or basic software proficiency. As a unique discipline, it requires specific frameworks, metrics, and developmental standards. The task ahead is building the architecture required to manage this